Okay, let's look at this next sucker. It's called front-end estimation. I didn't know there were types of estimation until I started teaching this class. I forgot. Okay, so let's say we have these four numbers added together and I want to use front-end estimation. Well, first we have to figure out what the largest place value is. So this 977, that's 100. This 3398, that's like 3,000. This 4024, that's 4,000. That 3603 is 3,000. Anyway, so the highest place value is thousands. Now it says take the digit from every number in that place and add them. So let's go back and look at all my numbers and take everything that's in the thousands. 3,000, 4,000, 3,000. Yeah, that's just it. Okay, so 3 plus 4 plus 3 is 10. Now it says multiply your result by whatever place value you used. So that 10 we just got times the thousands, that was our place value, is 10,000. Okay, now let's see. Let's deal with everything else that we have left. It says now you have a 603, 24, 398, and 977 to deal with. So we took off all the thousands. Pair them up according to which ones approximately add to a nice number. Nice numbers are multiples of 100. If we have a loner left over, we would round him to multiples of 10 and add him in the last step. Okay, so out of 603, 24, 398, and 977, we're trying to add two of these to get to something that is either 500, 600, 700, 800, 900, 1,000, 1,100, 1,200, 1,300, something with 100 on it. Okay, so I think if I maybe add this 24 and 977, we get something close to 1,000. Yay. Then if I get 603 plus 398, that's also close to 1,000. Yay. So now it says finally add step 2 and 4 for estimation. So from step 2, we said that the 1,000 place values will add up to 10,000. Then in step 3, we saw that our numbers can pair up to 1,000 and another 1,000. And that adds up to 12,000. And that's called front-end estimation. Okay, let's do another one with these 5 numbers. First, we have to decide what the largest place value is. Well, this looks like 400, 400, 900, 500, 200. Yep. The largest place value is hundreds. Now we're going to take the digit from all the hundreds. 4, 4, 9, 5, 2. Let's add those up. 4. And we get 17, 22, 24. Okay. So we've just done step 1. Step 2 says multiply your result by the place value that we just talked about, hundreds. So 4 times 100 is 2,400. Yay! So it's like we just estimated all the hundreds. Now, what do we have left? We have left a 14, 68, 57, 29, and 85. Okay, let's try and get these to add up to some kind of a 100. Either 100, 200, 300, 400, 1,000, something like that. But either way, it has to add up to something with some zeros on the end. So let's see here. I think 68 and 29 add up to 100-ish. They don't actually, but they get real close. Let's see if anything else adds up to 100. 14 and 85. Those are pretty darn close to 100. I think it's like one off, but close enough. Okay, so this is step 3. It says pair them up according to which ones will approximately add to a nice number. We already did that. If we have a loner left over, we should round him to a multiple of 10. Okay, so my loner is this 57, and we're gonna round him to a multiple of 10, like 60. So we didn't round him down to 50 because 60 was closer. Okay, now we're gonna add up the number from the hundreds, 2400. Then the 100-ish, and the 100-ish, and then the loner of 60. Let's add all that up, and we should get 2660. Yay, front end estimation. Okay, let's look at something called low or a high estimate. It's pretty easy. It says round your low or your high number to a nice number, things that have zeros in them, like 100, 200, 300, 400, 1,000, something like that. So let's look at this example. We need to round that 116 down to a low estimate. So let's round him to 100. We have to round things to stuff with OOs on them. Okay, that 442, again, we're rounding low down. So that would round to 400. And if I add those, I get 500. So that would be a very low estimate. A very high estimate would be where you round all these numbers up. 116 gets rounded up to 200. 442 gets rounded up to 500. Add those together and you get 700. So if we were asked for a range of low and high end estimates, we'd say from the first addition 500 to the second 700. Yay! Okay, let's learn about doubles plus. Some of us do this in our head accidentally. Some of us have never seen it before. Basically, you turn everything into a double, or you try and turn it into a double. Okay, let's say we're doing 16 plus 9. That's the same thing as 9 plus 16. It says change the first number or the largest number. So my largest is 16. So we have to change that largest number of 16 to something plus the second number. Well, we have to do something plus our second number is 9. So let's see here. What plus 9 does give you 16? Well, 7 plus 9 gives you 16. So we change this first number of 16 to 7 plus 9. And then you keep that last number there. See, plus 9 plus 9. Then you regroup the parentheses using the associative. So the parentheses get moved around the 9 plus 9. And the 7 is just hanging out in front. Then it says add the doubles inside the parentheses. So 9 plus 9 is 18. And then there's still a 7 in front. And when you add those, you get 25. Let's do another one. 24 plus 27. First, let's figure out what the largest is. The largest is 27. So now we're going to write him as something plus the second number. And if the largest is 27, the second number is 24. So it doesn't mean the second number in the list, it just means the other number. Okay, so I need something plus 24 to give me 27. So what plus 24 gives me 27? And the answer is 3. So the first step said change the first number to something plus your second number. So we just did 3 plus 24. Then I'm going to add on that second number, 24. So all I did was rewrite this 27 as the other number, 24 plus 3. Okay, then we use that associative identity, which says we can move parentheses however we want when we have plus signs. Then we use the doubles. Double of 24 is 48, and then you add it up and you get 51. Yeah. Okay, again. This next one is called the opposite addend to add. The key word there is opposite. Don't get crazy about this word addend. It says use the opposite change algorithm to compute 569 plus 253. So first we ask ourselves, which one is closer to an even 10? As in 560, 570, which one's closer? 569 is closer to 570, and it's only closer by 1 away. What would 250 be close to? Sorry, 253 would be close to maybe 250 or 260, but either way, 569 is only 1 away from a 10. One more and you get 570. So it says, which is closer to an even 10? 569 is closest to a 10. It's only 1 away. Okay, so what you add to one, you must subtract from another. So we're going to say, okay, to get this 569 to a 10, we're going to add 1. And whatever we add to him, we're going to subtract from the other guy. So I'm going to add 1 to 569 to get 570, but then I'm going to subtract it from the other sucker, because what you do in math, it has to be always equal, even. Okay, so 569 plus 1 is 570. 253 minus 1 is 252. Now it says, next, find a friendly number that can be added to 570 to get a type of 100. Okay. So, how do we get from 570 to a type of 100, which is 600? So what plus 570 gives you 600? And the answer is 30. And then it says, now what you add to one, you must subtract from another. Oh, I was wondering where the rest of the paper was. Here it is. Okay. So we added 30 to get 600, but when you add 30, you also have to subtract 30 to this last 252, and you get 222. Then it says, now that you have an easy multiple of 100, add the results. So this 600 plus this 222 makes 822.